So the first thing that I notice in this problem is that I don't have anything equal to 0. So really, that's the very, very first thing that you need to do when you see a polynomial, is make sure that everything, the polynomial is all on one side and it equals 0. So I'm going to rewrite this 2c to the 4th minus 6c to the 3rd. I'm going to subtract 12c squared and then add 36c to both sides. And so now I have everything over here. So when you have terms on this side and you want to move them to the other side, you basically, I envision them coming off the page, moving over, and the sign changes. So this one, 36c, comes over here, and it becomes a positive. Okay, and now I notice that I can factor out a 2c. So I'm left with c to the 3rd minus 3c squared minus 6c plus 18 equals 0. Okay, so I have a polynomial with 4 terms, so I'm going to try to graph it by grouping. So for this part, I can factor out a c squared, and I'm left with c minus 3. Over here, I'm going to factor out a negative 6, okay, because I need c minus 3 to be here. So negative 6, this is a c minus 3 equals 0. So what I have is 2c times c minus 3 times c squared minus 6 equals 0. So this is this polynomial factored. So now how do I find the zeros? Well, one of my zeros is right here, okay, because if that's 0, this whole thing is 0. Okay, another 0 I have is 3, but what about this one? What values of c make this 0? Well, I can always come over here and just set it equal to 0 and c. So I take the square root of that. So c is plus or minus the square root of 6. So I've got the square root of 6 and I have negative 6. And you can write it like this too if you want. But there are 4 of them, and that makes sense too because I've got a 4 right there. And we'll learn more about that too another time. Okay, so this wants me to sketch a graph. So I'm going to erase this part. And what I have here, I know by looking at it, it's positive and it's of even degree. So it's going to look something like this. Okay, so I've at least got that in my mind. And I know that the zeros are at 0, 1, 2, 3, and plus or minus square root of 6, which is roughly 2.5. So it's going to cross here and also right here. Okay, so if I just draw a rough sketch, I know that this is going to go on from here, right? And I don't know how far that comes down, but it's going to come down so far, and this is going to come up. Oops, I totally missed it. Okay, this is going to come down, and maybe it's just a really quick loop like that. Okay, so those are my zeros. This is basically what I think the function looks like. And I know it's hard to tell on this one, but I put it in Desmos, and it's actually really, really steep. So this is going up, this comes way down, comes way up, has that little blip right here, and then keeps going. Okay, now what about x cubed minus 8x squared plus 11x plus 20? It's got 4 terms, right? So I'm going to try to factor it by grouping. Well, if I look, I can tell that I can't do that. So right now, I don't have the tools that I need to factor this so that I can solve it. So we're going to talk about the rational root theorem, also called called the rational zero theorem. We call it the RRT, the rational root theorem. And it's on page 147 in your book. Okay, so if f of x is a polynomial and it has integer coefficients, so there's no 1/2 x squared or there's no square root of 3 times x, there's nothing like that. These are integer coefficients. Then every rational solution of f of x equals 0 has the following form. Okay, so if I have a polynomial with integer coefficients, then it means that any of my zeros are going to be in this form. Okay, this right here is the constant term over the leading term. So it's the last term over the first term. All right, so let me show you an example. So this is the one I just showed you. All right, and this is how you would solve this problem. And I'm going to try to get it in the next couple minutes. Okay, so what the rational root theorem says is that I have factors of the last one over factors of this one, which is just a 1, my coefficient. Okay, so and this is kind of an easy one because all of this is just going to be over 1. But what I've got here is I've got factors of 20. So I've got 1, negative 1, 2, negative 2, 4, negative 4, 5, and negative 5. Okay? And they're all over 1. So when I'm solving this problem and I'm looking for what x is, the rational root theorem tells me that it has to be one of these. It's not going to be like x is 7. Okay? And so that helps us to at least really narrow it down to what it is that we need to look for. So what is it that we need to look for? We need to look and see if any of these are zeros. And we can do that by using synthetic division. So I want to check and see if 2 is a 0. So I'm going to come over here and I'm going to put it into the polynomial. So I've got 1, negative 8, 11, and 20. So drop the 1. This is 2, negative 6, negative 12, negative 1, negative 2. Okay, so 2 is not one of my zeros. And you can see how this could take a while, all right? But let's try another one. Let's do 4. And I have 1, negative 8, 11, and 20. So I drop the 1. 4 times 1 is 4. This is negative 4. Negative 16. This is negative 5. 4 times negative 5 is negative 20. Here's my 0. So this tells me that 4 is one of my zeros. Now I can factor the rest because I have x squared minus 4x minus 5. Once it gets down to an x squared, we can either factor it or we can use the quadratic formula to find the other values of x. Okay, so I'm going to factor this really quick. So this is x minus 5 times x plus 1. Okay, so one of my zeros is 4. I knew that already. Another one makes this 0. This is a 5. And this is negative 1. So that is how we do that one. I am way over time. Okay, and this is what it looks like. So we have negative 1, 4, and 5. And I will continue in the next video.